So when we left off in the last video, we were having you do a couple of rearranging equations as well as looking at this green page 7. So continuing on from there, we have rearranging the equations. So if you rearrange the acceleration equation to solve for t, you will end up with VF minus VI all over A. And it'll be important that you do that subtraction as a quantity. If you need to, put parentheses around the outside of that. Number 4 was rearrange the acceleration equation to solve for VF. So with this, you end up with A times T plus V sub I. And if you rearrange that for V sub I, you are going to end up with VF minus AT. If you are struggling with this, I suggest you go back and review the videos about rearranging equations, and we had done some practice work on this previously. If this is a struggle for you, you do want to speak up. This is a skill and a tool that you're going to use throughout this year and throughout next year. So we want to be sure that you're successful with this. If you do need help, you can also go to math tutoring for assistance in just rearranging these kinds of equations with variables. So the top part of the page, the first thing was reviewing the instantaneous velocity of an object is the speed of the object with a direction. Remember, velocity is a vector and it needs a direction. Number 1, accelerating objects are objects that are changing their velocity. Name the 3 controls on an automobile that cause it to accelerate. So to speed up, you're going to use the gas. To slow down, you're going to use the brake. And to change direction, you're going to use the steering wheel. Number 2, an object is accelerating if it is moving blank. Circle all that apply. So if it's changing speed, it's accelerating. If it's moving in a circle, it's accelerating. Extremely fast, downward, constant velocity, none of those have to do with acceleration. So the only answers are A and D. Number 3, if an object is not accelerating, then one knows for sure that it is moving with constant speed and maintaining a constant velocity. So you don't know for sure if it's at rest because it could be moving. Do these questions seem similarly worded to ones that you've seen in the MOP app? They should, and you can anticipate that you're going to see things like this in an upcoming MOP app about acceleration. The bottom of the page. Acceleration as a rate quantity. So this is where you're going to be applying the equation and understanding it. So number 4, an object with an acceleration of 10 meters per second squared will be changing its velocity by 10 meters per second every 1 second. Number 5, Ima Speedin puts the pedal to the metal and increases her speed as follows. 0 miles per hour at 0 seconds, 10 miles per hour at 1, 20 miles per hour at 2, 30 miles per hour at 3, 40 at 4, etc. What's the acceleration of her car? Her acceleration is 10 miles per hour per second because her speed changes by 10 miles per hour each second. You can do that by plugging it into the formula, or you can do that just by reasoning it out. Number 6, Mr. Henderson's imaginary Porsche accelerates from 0 to 60 miles per hour in 4 seconds. Its acceleration is what? And it is 15. So if you go V final, which is 60 miles per hour minus 0 over 4, you end up with 60 divided by 4, which gives you 15. And the units are miles per hour per second. Remember, I told you that most of the time we like to keep the time units the same, so you end up with a time unit that's squared in the denominator. Sometimes we don't do that, and it's just for convenience. For this one, it's just much easier to just leave them as they are. Number 7, a car speeds up from rest to 16 meters per second in 4 seconds. Calculate the acceleration. So we show the math here. The final velocity is 16, the initial velocity is 0, and you divide it by 4. So 16 divided by 4 is 4 meters per second squared. And the car slows down from 32 to 8 in 4 seconds. So you're calculating, you got a negative number, 24, and divided by 4. So most of the time, I'm going to ask you to put a direction here. So I'm going to suggest you put that here. So for this 4 meters per second squared, let's put forward. And for the -1, you're going to write equals 6 meters per second squared backwards. And that tells you that it is slowing down. So it is going in the opposite direction of which the car is moving. Okay, so now on the green packet, page 8, I am going to go over this top part with you, and the bottom part of the page is for you to fill in on your own. So acceleration is caused by a change in speed or direction or both. So the example they used here was speed is beginning a drag race, direction is turning. Both could be slowing down on a curved off-ramp. So the units are going to be meters per second, which is the same as what they wrote here, meters per second times 1/second, and that gives you meters per second squared. Remember, the hats are the little vector quantities, V2 minus V1. You can have things like meters per second or kilometers per hour for your change in velocity. Time is usually seconds or hour, and this means change in time. So you've got a change in velocity over a change in time. And so acceleration is known as the rate of change of velocity. Anything you have that is divided by the time frame, it's going to be a rate of change. And you can have that with anything. You can have it in cooking and baking and driving and moving. So a rate of change is when something changes with respect to time. Acceleration units measured in meters per second squared is very common and easily used. So you end up having 2 problems underneath this. So take your best guess at this. Remember, as I'm looking at these for corrections, I am just paying attention to whether you attempted it. I don't expect you to do everything perfectly the first time. If you're uncertain, write it in pencil so that when you come back, you can rewrite it in pen if you like to write in pen. But make an attempt at this before you watch the next video.